Hi guys, how are you today? My name is Julian. I'm your TA of CS 4379 this semesters, and today I want to do a mini tutorial about recursion. And there might be some of you that have a little struggle with this topic because it is a quite tricky topic in computer science, and I was pretty struggle with it when I first start. So I hope this helped a little bit. So what problem today is I want so a countdown we want to implement a countdown function where we take a input n and we want to print out the numbers of n minus one, n minus two until one with the method of recursion. So I wanted to start, and you likely to know that recursion is basically recursion is a function call itself. So I want to just try to a print out n when we call it itself, so to see how C++ would react to this behavior. So it's called countdown. So we'll print out n and we call the function itself. So let's see what's going on here. So since if we call the function is we took n and we print out n and we keep call countdown n, it will just start the function just start calling itself, and and the compiler doesn't know where to stop. So this result in a infinite recursion. So let's just try n minus one, say, to see what's going. So of course it's the same as the previous case, but when the compiler there's no they don't it doesn't know where to stop the recursive call, so it just keep printing n minus one. So that's why we have thing it calls here is a base case. So when we want to n stop at one, so if we have n less than one, we just return here nothing here. This is where it stopped. So let's run it. Yeah, there you go. So when we have from 5, 4, 3, 2, 1. So what happened here is start from the main. When you call a function countdown of five, the call stack is on the push a function called five in here, and whenever a recursive call um, within the function starts triggers, it's gonna call it's it will put it to the call stack. So we have five, so four, so we have say first we have five right here, right? So five is not less than one. Print out the output's gonna print five. Countdown n minus one is four. So call stack is now um so this ministry is this is a better way to visualize the call stack. So five is put in first, four. So we have four. Um, four minus one is three. So three is not less than one. We push three in. Output here is three, and we have three at this point. Three minus one is two. Push in the stack. Two is not less than one. Print out two, and one is not less than one. So one here, one cut down zero. So since zero less is not less than one, I'm sorry. So since zero less than one, the recursive goal is need to stop. So so using this concept, we can and a little modification of this function, we also can print out the number from one to n if we applying this call stack concept. So instead of push down, put instead of put, we're using tail recursive here. So same thing, exact same thing happened at the previously. So we have for stack of five. It's not printing, so it's not there's no printing statement before this. So there's no this is no output right now. So we have five, four, three, two, one, and the and so sorry, actually five, four, three. This is how actually stack work. So one. So so when it reach into the base case, there's more end to call. It will reach number 12 here. So return, there's no base return. It will reach to 13, the line 13, jump back to to line 12. So now it will start to print out the stack. So we have one, two, three, four, five until it reach all, and whenever it called, the stack will be canceled. So one, two, cancel three, cancel four, cancel five until the stack empties. That's when we have all this output here. So let's run it. There you so we have one, two, three, four, five now. So it looks good now, and I think that's about it. I think it's a very simple problem, but this will it's basically demonstrate how recursion work at the very basic problem. These are very basic terms. So I hope this helped a little bit. Maybe a refreshment for those of you who kind of forget kind of forget how recursion works. So yeah, that's about it. Thank you guys.